Hi everybody, we are today working still in Module 1. We are in Topic 2. We are on Lesson 3. We're going to do the introductory lesson, and then we're going to move on from there. For right now, we are starting on page 87. So length, width, and depth, deepening the understanding of volume is what we are on. Okay, so our terms in this lesson: volume, geometric solid, polyhedron, face, edge, vertex, unit cube, right rectangular prism, and cube. We're going to talk about all those words. Our goals for this lesson: determine the volume of right rectangular prisms with fractional edge lengths using unit cubes with unit fractional dimensions. That sounds just like a bunch of nonsense words right now, but I promise that'll make sense here soon. Determine the number of cubes with unit fractional dimensions that have the same volume as a unit cube. Determine the number of unit cubes with unit fractional dimensions that can pack a rectangular prism with fractional edge lengths. And connect the volume formulas: capital V for volume equals length times width times height, and volume equals capital B times height. And there's that capital B that I was telling you guys about before, that I said I didn't want you writing the B for base as a capital, and that we would be using it in a capital form later on. So we are to that moment. Okay, so moving on here. It says determine each least common multiple. So our numbers here are pretty small. So for these multiples, we could probably just count by each of the numbers. So we have 2 and 10. So 2, 4, 6, 8, 10. And then if I count by tens, I start right here at 10. So the least common multiple for 2 and 10 is in fact 10. If we thought about the table that we did for prime factorization, the prime factorization for 2 is just 2. And for 10, it's 2 times 5. And remember, for least common multiple, all of the columns get shown. So we have a column of 2's, a column of 5's. So our least common multiple is the 2 times 5, which is the 10. So we have it that way as well. 3 and 8. So again, we could count 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, so let's do 8, 8, 16, 24. Oh, right there is our first multiple. And again, if we did the table, let me just kind of draw kind of a line here to box that off. If we had 3, prime factorization of 3 is just 3. And for 8, it's 2 times 2 times 2. So remember, we won't put it here. It has to be the same number. 2 times 2 times 2. Nothing goes there. And then to show the least common multiple, every column gets shown. So we have 3, 2, 2, 2. And when you multiply those straight across, we have 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So our least common multiple of 3 and 8 is 24. 6 and 14. I'm just going to go right to the prime factorization for this one. So the prime factorization for 6 and 14. So 6 is 2 and 3, all right? So if I did the factor tree, 6 is 2 times 3. 14 is 2 times 7. So they both have a 2. The 6 has a 3, the 14 does not. The 14 has a 7, the 6 does not. The least common multiple, every column is represented. 2 times 3 times 7. We end up with 6 times 7, so our least common multiple of 6 and 14 is 42. And then finally 10 and 15. So our factor trees for 10, 2 and 5. For 15, we have 3 and 5. So 10, 15 is common multiple. 10 is 2. The 15 does not have a 2. The 15 has a 3. The 10 does not. And they both have a 5. Each column gets represented. So 2 times 3 times 5 equals 30. That would be kind of easy to count by the multiples. 10, 20, 30. 15 is 15, 30. Okay, so that's page 87. Says here at the bottom, you know about three-dimensional figures such as cubes and other rectangular prisms. You also know how to operate with positive rational numbers, which you've always worked with positive numbers. You can calculate the measurements of any rectangular prism, even one with fractional edge lengths. So that's what we're going to do. We're skipping the getting started for now. It is a rather interesting problem. If anybody wants to try that and turn it in, I would consider giving you an extra credit point if you could write out an explanation as to how you could do that. It's a fun problem. I'm going to challenge you to think about it. Just say, remember, volume is the amount of space occupied by an object. You measure the volume of an object in cubic units because we're measuring 3 different dimensions. So length times width times height, measuring length times width times height. This was a bit darker. So if we did inches, it'd be inches times inches times inches, or inches cubed. Okay, moving on now. Activity 1. So this is on page 89. Volume of prisms. I do want you to just kind of pause this as you need to. I'm going to read down over it, but if you want to pause it and read it on your own, that would be fantastic. And you could probably get more out of it actually. So I think you should do that. Our habits of mind: reason abstractly and quantitatively. That means about numbers, like quantity. Construct viable arguments and critique the reasoning of others. Volume of prisms. Recall that a polygon is a closed figure formed by 3 or more line segments. A geometric solid is a bounded 3-dimensional geometric figure. A polyhedron is a 3-dimensional solid figure made up of polygons. A face is one of the polygons that makes up a polyhedron. An edge is the intersection of the 2 faces of a 3-dimensional figure, and the point where multiple edges meet is known as a vertex of a 3-dimensional figure. So basically, a polyhedron, it's a 3-dimensional shape that the different sides of it are polygons that we know, shapes that we know. A face is the side of it. If you could picture like being able to touch this, it's the part that you can lay your hand on flat. Like my phone. This is a face of the phone. I can lay my hand on here. I can lay my hand on this side. I can even lay my hand on this side. So this is a face of it. Okay. If I was thinking about this as a rectangular prism. Okay. Then the place where the 2 faces come together right here is called the edge. And the point where 3 of the faces meet is called the vertex. They kind of form a V. Like here's an upside down V right here. If we're talking about this one here, down here at this corner, you can see right here, like a V is formed. Okay. A right rectangular prism is a polyhedron with 3 pairs of congruent and parallel rectangular faces. Congruent meaning the same. Figure B is an example of a cube, which is a special type of right rectangular prism. A cube is a polyhedron that has congruent squares as faces. So all the sides are the same. So on figure A, this front face would match with the one on the back side. The top and the bottom would go together, and then the ends would go together. In class, I'll have a cube to show you that, or a right rectangular prism and a cube for this one to show you that. So if you're watching this because you're absent when you return to school, make sure you ask me and I will show you these shapes. Okay, so consider the fish tank shown. We better hop up here. Did you know a unit cube is a cube whose sides are all 1 unit long? Number 1, consider the fish tank shown. How can you determine the volume of the fish tank? Well, and we read on the previous page that volume is found by multiplying the length times the width times the height. Length times width times height. Please write that down. Remember, when the 3 letters are put right next to each other, it implies that there's multiplication going on in between. So then it says, how many cubic inches of water can the tank hold? So our length is here, our width, and our height. So volume equals length times width times height. And you don't have to put the dots for the multiplication. The 3 letters sitting side by side imply multiplication. When you rewrite it with the numbers, you'll either need to show the multiplication symbols or you need to use parentheses. So length is 50, width is 25, and then the height is 30. So you could also write it like 50 times 25 times 30. The first one could be in parentheses as well if you wanted it. Okay, so what does that equal when you multiply those out? Okay, so here we go. Let's, I'm just going to pull up the calculator to show you. I know what it is already, but I do want to just show you it. Okay, so we have 50 times 30, which is going to be 5 times 3, which is 15, and then 2 zeros. So we should get 1,500, which we do. And then we have the times 25. So 37,500. Our volume equals 37,500 inches cubed, or cubic inches. Either way you can write that. Number 2, a planar box in the shape of a rectangular prism has a length of 3 feet, a width of 1 foot, and a height of 1 1/2 feet. How much potting soil can the planter box hold? So I'm just going to highlight what they're telling me. So I have a length of 3 feet, a width of 1 foot, and a height of 1 1/2. So my length equals 3, my width equals 1. That's in feet, feet, feet. They're all in the same unit, so that's fine. And then my height is 1 1/2. So again, you must write the formula. Volume equals length times width times height. And now we're just going to substitute in. I know my length. I've read it from the problem and I identified it here. So my length is 3 times my width of 1 times my height of 1 1/2. So then when I multiply these, 3 times 1 is 3 times 1 1/2. So if I turn that into an improper fraction, 2 times 1 is 2 plus 1 is 3. 3 halves times 3 over 1. Multiplying straight across, I get 9 halves, which is the same as 4 1/2 feet cubed. Okay. And again, if you need to pause, please do so. We're going to move on though to page 90. So it says, recall that you can calculate the volume of a rectangular prism by packing it with unit cubes. I'm assuming it says recall this because I'm pretty sure that if you would have Carnegie Learning in 5th grade, this is something that you would have done in there. So this may be the first time that you're seeing this concept, so don't worry that it says recall. We're going to go over it right now. So the worked example, you can pack the prism shown with 7 unit cubes along its length, 3 unit cubes along its width, and 5 unit cubes along its height. So if I had this empty rectangular prism that I could fill with these cubes, they're saying each of these cubes is 1 inch by 1 inch by 1 inch. So I could fit 7 of them going across this way, 3 going across this way, and 5 high. It says there are 7 times 3 or 21 unit cubes in each layer. And that does make sense. So if we look here at the bottom, we have 7 going this way and 3 going this way. So 7 times 3 is 21. And then we would have 5 layers of the 21. So if we continue to fill each of these layers, we'd have 5 layers with 21 in each. So 21 times 5 is 105 cubic inches. Consider the formulas for volume of a prism and area of a rectangle. Volume equals length times width times height, and area equals length times width. So here's a new concept, and this is where we're going to refer to this capital B. If you use a capital B to represent the area of the base of a rectangular prism, then you can rewrite the formula for area is capital B equals length times width. So that capital B stands for area of the base. Please write that down. Area of the base. And then number 3 says, how does the formula V equals capital B times H? So how does the formula volume equals area of the base times the height? So what do you think? How does it relate to that? Well, capital B is the area of the base. In the worked example. The area of the base, the capital B, is the same as length times width, the length times the width, and the area of the example. Just making sure you have time to write this down. So to determine volume, you multiply the capital B times 5. Capital B is the area of the base, so that's 21 times 5. Using both of these formulas, you can rewrite the formula for the volume of a rectangular prism as volume equals capital B times H, where V represents the volume. So I want you to highlight this or underline it, circle it or something. B represents volume. B represents the area of the base, and H represents height. Please highlight that, underline it, box it, circle it, do something. Consider a cube that has side lengths that are each 1/2 of an inch. Each side of the half-inch cube is half the length of a unit cube. Right? A unit cube, a unit, is 1 inch. So it takes 2 of these cubes to measure the same length as 1 inch. Here's a unit cube. It goes 1 full inch. A half-inch cube takes 2 of them to go the whole inch because it's half an inch, half an inch. Half and half is 1. So then it says, how many half-inch cubes does it take to fill the prism from the worked example? Philip says it will take twice as many cubes to fill the prism. Mara says it will take 4 times as many cubes to fill the prism. And Daniel says it will take 8 times as many cubes to fill the prism. Who's correct, and explain your reasoning? So I definitely want you to pause here and think about this. Okay, so who is correct? So if instead of a 1 inch, instead of these just being 1 inch going across, if they were just half an inch, how many would it take? Well, how many of these half-inch cubes would be in this unit cube here? Well, if I kind of draw that across, I know down here in the bottom, there would be 2 going across. They would go across to half an inch, and then there would be another layer going up. And then I can think about that kind of going back here on the side as well. And across the top. So how many cubes would there be? The bottom layer would have, just think about that, 1, 2, 3, 4. So there would be 4 on the bottom layer, but then there's 2 layers. So there would be 8 in every cube. In every one of the 1 inch cubes, it would take 8 of the smaller half-inch cubes to fill it. 2 across here, 2 back, and 2 high. So I think, who's right then? Daniel takes twice as many. Mara says 4 times as many, or Daniel says 8 times as many. All right, it is Daniel. So Daniel is correct. To fill the same space as a 1 inch cube, you need 8 of the half-inch cubes. Now I know you want to think, well, half and half is a whole one, so why don't you just need 2? Because the 2 would only fit going across here, right here in the very front. Right? So I would still have this whole back layer here available and the whole top. This would just fill part of it in the front. Okay, so there's 4 across the bottom. across the bottom layer and 4 on the top layer. Okay, pause if you need to so that you can write that.